Hi, welcome to Transatlantic-shoulder-ecourse. My name is Bruno Gobbato. I'm speaking directly from Brazil, and I'm going to show how we can do 3D planning in a very do-it-yourself way. So thank you again for this wonderful opportunity to be here. I'm an orthopedic surgeon in Brazil. I'm also a shoulder and elbow specialist. I have no disclosure for this presentation, but I have one disclaimer. The softwares I'm going to use here are free. Everyone can download and use it free for Mac and Windows, whenever platform, but they are not for medical use, so they don't have FDA approved and Visa approved, so use as your reference. But these are not medical softwares. That's an important disclaimer for this presentation. We started using 3D printing in 2013. We are developing apps since 2010. And we started our planning doing very simple things. For example, for a clavicle fracture, this is an old example how we can use 3D printing to choose our implant or to do something like that. Then we moved to digital planning for clavicle fractures, actually for any surgery. And of course, we know that shoulder arthroplasty is one of the most important ways to plan, and then one most important surgeries for us as surgeons to have a good planning. Sometimes we have some retroversion and some inclination, like this case, and sometimes we have some bad glenoids and some very bad glenoids, like this example. Here are some examples. This is one type of guide, one type of planning that we made through the Tournier software. There are lots of softwares available in the market, but we are going to show how we can do it in a more simple way and more wide way to 3D print and 3D plan your surgeries. With that, you can plan graft, you can plan osteotomies, and you can plan almost everything like this planning we have just did here. Here is an example of a 3D printing and a planning, in this case using a patient-specific graft for this case. And how we're going to do? Well, we're going to need two softwares. The first one is Invesaglios. You can download it free. It's a software that we're going to transform our CT DICOM files into a real 3D file. And then we're going to use a software called Mesh Mixer. It's also a free software that we're going to clean, separate the models, and do some basic planning. So let's exit our presentation and let's go to the computer screen, because this is a very hands-on. So we're going to open our software. This is the software that I'm talking about. This is called Invesaglios. This is a Brazilian software, but it's well known all around the world. Okay, this is the version I'm using. It has 4 simple steps. The first step is to open the DICOM files. So we're going to select the file or the folder that our CT scan is saved. Here we have the CT scan. We're going to open this. This software is a DICOM file software that you can use to see your DICOM files, to see your exams, as any other software. So here we have all the views that we have for the software. We are going to select the axial view. Okay. We're going to select the smooth part window. Okay. Not the bone window. This is the bone window and this is the smooth part window, and we're going to select or click and import. Okay, this software is in Portuguese but has translation for almost all languages. So the first step is import. We have already imported. Now we're going to the step number 2, that we're going to select the threshold for the tissue that we want. In this case, the tissue that we want is bone. Okay, so we're going to do the thresholding. If we do that, everything is select. If we do that, nothing is select. So we're going to move our threshold until we have a good amount of bone selected but without any muscle or other tissue. And here we can drag and we have everything painted in green in this case, and it's okay. Let's go to create surface. So just click on create surface and the software will do some calculations slice by slice and create a 3D view from each of the slices that we are painted. So everything that is in green in this case will be transformed into a 3D editable file. So now it's done. We can see here we have a shoulder with the clavicle, the ribs and everything, and it's done. We just need to go to step number 4 and export the surface. So click here, let's click on our folder and we're going to export to Alps Nyon. We're going to select the STL file, which is the file that we use for this purpose. That's okay. We already have our 3D file that we can manipulate and see in any ways, but we do not need anymore the Invesalio software, so we are going to close. Perfect. Now we are going to go to our other software called Mesh Mixer. Okay, this is the software that we are using, Adobe Mesh Mixer. This is the version I'm using. It's also a free software. So I'm going to import, not open, import. Let's choose our file. It's here. Okay, Alps Nyon. Okay, great. Now we have imported our file. We are going to select everything that we want to do. So in this case, we have the ribs, we have some trash that we don't want in our planning. We just want for this purpose the part of the glenoid, the scapula. So we are going to delete everything that we don't want. So first step, we choose the select button, select, and then I'm going to do the double click on the scapula. Okay, the scapula and the humerus was selected. Now I'm going to go to invert this selection, okay, because I want to delete everything else. So we are going to invert, modify, invert, or the I key. Okay, now everything else is selected. I'm going to just click the delete button to delete everything. So, okay, now we have everything deleted. We have only the scapula and the humerus. So if we're going to plan a shoulder arthroplasty, we should divide this scapula and this humerus. We know they are touching, that's why we cannot separate, and that's very common when we see a huge arthritis. So we're going to delete ourselves. We're going to select again the select key button, but in this case we are going to click outside the model, and I'm going to drag and draw around the part of the tissue that I don't want in my planning. Now it's going to select everything. I'm going to click on delete again to delete a good amount of the humerus. Now I have to do some simple and some more selections in order to delete this part of the humerus. I'm going to paint everything that I don't want. Again, I'm going to paint the tissue that I don't want and delete everything that is not in that I don't need. I just want, for this case, the glenoid. I'm going to select again the glenoid. Let's see. Okay, everything is selected, so something is touching. So I think here. So we need to delete this small part here. I'm going to just draw around. Hit delete. Again, hit again 2 times on the scapula. Now we see that the part of the humerus is not being selected. So we can do again the inverse selection. Modify, invert. Now only the humeral head is selected. I can click on delete. Okay, now we have our scapula. I'm going to click on analysis and inspector. This inspector will correct some errors, for example this part that I have deleted, and it's okay. So one thing that we can do right now, we can export for 3D printing, and we can evaluate somehow this glenoid. One tip that I can give to you is to do a cut on the scapula. For example, I move and I go to edit, plane cut. I select where I want to cut. I click accept, and here I have a cut of the glenoid, and I can draw some lines and evaluate the retroversion. But I'm going to click Ctrl and Z to go back, or Command and Z to go back, because I don't want to delete. And now I'm going to do a simple planning. I'm going to import an implant from my implant database. I'm going to just click on import, append here, and now I'm going to select a base plate from a company. How did I got this base plate? Well, I just exported from a patient CT scan. We can export the metal file, and here we have the base plate, as we can see here. Now we are going to do a simple planning, moving this base plate through the location that we want, moving forward and backward, just like that. Now we just need to move a little bit like that, rotate, move closer, upper, and now we have some basic planning. We can see that the position is not that great, so let's change the orientation. Let's move a little bit further, and here we have some example of our planning. Okay, one thing that we can do to check if everything is in the correct position is to click on height, and here we can see in a more transparent way how the planning is done. If we click again, we are okay, and we can do again the plane cut tool. So we can cut around here, we can do accept, and we can make sure if our implant is in a good position. So if I'm okay with that position, I'm going to click Ctrl or Command Z again to go back, because I don't want to cut. And in this case, what matters me is not exactly only the position of the base plate, but the position of the central pin guide. So I can click on the implant. I'm going to select the implant and delete. So now we have the two models. We have the glenoid and the central pin, and this is the location that I need and the direction that I need to do my reverse total shoulder. If I want to create a patient-specific guide, I can create here in the software also a patient-specific guide. I can draw some simple solid over this glenoid and create a guide for this position. So this is a way how we can do our planning in a very simple and quick way. It's a basic planning, but can help ourselves in a surgery or for someone that doesn't have or that does not have the software available for the correct planning. And the beautiful about that is that we can now 3D print. We can 3D print this model. We can 3D print this model with the central pin already inserted. We can do everything that you want. We can export this model for virtual reality. So if we want to combine these two models, we can combine them, and we can, for example, export this printing or this model export, and now we have a 3D model that we can open for our planning. We can take screenshots, and we can also put in our augmented reality glass. We can open during surgery. We now have a 3D export file from our planning. So that's it. Thank you very much for watching, and bye bye.